Today we'll verify an important property of matrix inverses, that for two matrices A and B, the inverse of their product AB equals B inverse times A inverse in that order. Let's start with our two matrices. Matrix A is a 2 by 2 matrix with elements 2, 3 in the first row and 1, -4 in the second row. Matrix B is also 2 by 2 with elements 1, -2 in the first row and -1, 3 in the second row. First, let's compute AB. To multiply these matrices, we multiply each row of A by each column of B. For the first element, that's 2 times 1 plus 3 times -1, which gives us -1. For the second element, that's 2 times -2 plus 3 times 3, which gives us 5. For the third element, that's 1 times 1 plus -4 times -1, which gives us 5. And finally, for the fourth element, that's 1 times -2 plus -4 times 3, which gives us -14. Now, let's find the inverse of AB. For a 2 by 2 matrix, we first find the determinant. That's -1 times -14 minus 5 times 5, which equals -11. Then we take 1 over the determinant times the adjugate matrix, which gives us this result. Next, let's find B inverse. The determinant of B is 1 times 3 minus -2 times -1, which equals 1. Following the same process, B inverse equals this matrix. For A inverse, the determinant is -11, and A inverse equals this matrix. Finally, let's multiply B inverse times A inverse. When we multiply these matrices together, we get exactly the same result as AB inverse. This verifies that AB inverse equals B inverse A inverse. This is an important property of matrix inverses that we can use in our calculations. Remember that when finding the inverse of a product, we multiply the inverses in the opposite order of the original multiplication.